Today we're talking about Artist in Code, and the first thing that has maybe is the most obvious thing that you can see on the screen is that we now have an official site for it. So there is a website that you can see here under open source hltech.sw.com. And we have also made installations or releases. So it is now shipped for Visual Studio Code and available on the VS Code marketplace. This page also says that it works for Thea. It does to some extent, but we haven't yet published it on the Thea marketplace since there is an upcoming release that we want to test it with first, but hopefully that will happen quite soon. So if you want to learn about Artist in Code, this is the best place to start. Here is just some introduction on this front page with a video that goes through how to create a simple Hello World sample. When you feel that you want to read a little bit more, you can look here on the documentation. For example, installing goes through the step of installing. And when you need to kind of dig even deeper here into the language that we are implementing with this tool, you can read about it here in this chapter here, the art language. And there are other things also you can learn from here. Let's switch to the tool. And here I have installed the latest version of Visual Studio Code. I have also installed some C++, well, the C++ extension from Microsoft. So just like Artist is a tool for C++ developers on Eclipse, Artist in Code is a tool for C++ developers that prefer to use VS Code or Thea. So it's kind of assumed that the user starts by installing an appropriate C++ extension, and the one that we have tested with so far is the Microsoft one. There is another one based on the CLang compiler that we also want to support, but we haven't tested that yet, so I will not test that in this meeting. So now the first step I want to do is I want to install the latest version of Artist in Code, and I just need to type a few characters here to find it in the marketplace. So this is our latest version. It was released last week. So if we click the changelog here, we can see that, yeah, it was on January 26 with the released version 0.05. And here we are keeping track of all the improvements, so you can read about what has happened since October last year when the first public release was made. And you see we have great reviews, 5 stars all over and 87 downloads. So it seems to be a really good extension that I would like to try. So I click the install button and you get this little progress bar in the upper left corner. It takes around 20 seconds to download it and install it. So it's a much faster installation experience than Eclipse offers. And another difference is that you don't have to close and restart anything once you have installed. So I can now right away start to use it. However, I have noticed that sometimes it is good to reload. So you can do a refresh of the window just in case after you have installed something new. So now I have installed Artist in Code, and it appears here under the installed extension section. So if we go back to this web page, there is in the upper left or upper right corner a link to a GitHub repository. So we can open that in a new tab. This is our official GitHub repository where we put all our samples that people can start playing with, and also we have the documentation here. So the idea is that people eventually should be able to also suggest changes in our documentation, although of course that didn't happen yet. But here in the art samples folder, there are 2 samples, one Hello World sample and one ping pong sample that we can start by looking at. So to clone this, I will copy the location to that GitHub repo, and then I will just go here and clone the GitHub repo. And I need to provide a place on my disk where I can put it. So let's put it here. No, not got, but maybe Git. And now it's cloning that GitHub repo, which is quite small, so it goes quickly. So now here you could now choose to open it, but as I said, it's contains also like documentation and some other files, so it's usually not nice to kind of open it at the root level. So what you can do instead is that you can just open the folders that contain the samples instead. So if we go to this GitHub repo, it has these art samples, and here there are actually 3 samples, but the first 2 are completed. The third one is still a work in progress. So let's open both of them. And yeah, then we always get this prompt when we add something new. I think it is some kind of security question they ask, so we have to accept that we trust the content of these folders. So now, those of you who are familiar with Eclipse, I think, which we all are, see that this looks very similar to projects in Eclipse, but it's actually not a project, it's just a folder. Workspace folder is the term that is used. But we can have as many workspace folders as we like, and here I have now 2, one for Hello World and one for Ping Pong. So let's take a look at Hello World first, and the source of the applications has the extension art. This is the language that I showed you in the documentation that contains all the concepts that Artist supports, but in a textual form. So you will recognize here things like capsules. You know that all those of you who took the Artist course know what is a capsule, what is a port. We have state machines, we have states, we have transitions. So all the concepts, same concepts that you have in Artist, you also find here, but in a textual form. This is colorized according to some default scheme that VS Code decides by itself, but we also provide some other colorization schemes that are more kind of tailored to art development. And there are 4 ones provided: one Art Light, Art Light ++, Art Dark, Art Dark ++. So I will use the dark ones since I prefer the dark theme. So here you see now that it's slightly changed. In this language, within the backticks, we have C++ code. Just like you in Artist write C++ code in the code view or code editor, here you do it inline in the art file within these backticks. And with this theme, color theme, all C++ code is marked in gray font. So it makes it maybe a bit easier to see what is C++ and what is art. But there is also another that actually I prefer, where you can, it's called Art++, and then you get the same colorization of the C++ code as you would have if you would have typed this C++ in the usual C++ support in VS Code. So here you get, for example, keywords of C++ colorized correctly, and yeah, there are some other benefits also, I think. So at least I prefer this, but this can maybe be different from person to person, what they like. Of course, we also not only have text, because that would probably not be enough. So we have the diagrams, similar to what we have in Artist. And if I right click on this text and do open diagram, you will get the diagram open. But note this big difference compared to Artist. In Artist, you start by creating diagrams from a palette, and that is your main way of working and the way you input things. Here it is completely the opposite. Here you're primarily working with the text, which is very attractive for a developer who is good at manipulating text in this great text editor. And the diagram kind of updates automatically when you change something. So it's a dynamic view of the contents that you see here, but you see it's a much more high-level view. Here we can easily see that this state machine consists of an initial state, an S1 state, and S2. And I can use it for many things, for example, navigation. So if I double click on this S1 state, the cursor is selecting here the state S1 in the text, or S2, or if I go to here, the initial transition. You also see that there are blue icons here. They are the same as in Artist and mean that there is some code on this transition. So double clicking on that icon will highlight the corresponding C++ code. So if I, for example, want to edit what will happen when the state machine goes from S1 to S2, I just double click the blue icon for that transition, and I can change the C++ code here directly. So I think this is very, very basic things you can do to start with. So next, since this is a fully working example, let's take a look at what it's doing here. So we see that this state machine, it starts here and then it goes immediately to state S1. And while doing that, it runs the code that we have here. And yeah, those of you who know Artist recognize that this is exactly the same code as we have in Artist, because we are using the same C++ library as we use in Artist. So here we are setting a timer to expire in 2 seconds. And this timer protocol is defined up here, or timer port is defined up here using the predefined timing protocol. And then 2 seconds later, we expect the timer to time out, and then this transition will happen, S1 to S2 on timer timeout, and then we will write hello world, and then we will terminate the application. So let's now build this, and to build it, we need to have transformation configuration, same thing as we have in Artist. And I will just start by building it. Well, maybe I should also see here that I can set this as active, because just like in Artist, you can have multiple transformation configurations to build the application in different flavors. But here we have such a simple example, so we don't need any flavors. We can just build it right away. And then we get this question again, because now what happens is that C++ code is generated for this application, and it's put into a target folder, which by default gets its name from the top capsule. So you see I have specified the top capsule to be hello world, which is the name of my top capsule, and all the other things are kind of coming by default. So this is actually the only property you need to specify to have a working executable. And you get some nice printout here in the output channel, telling it that it starts processing this TC. It processes this art file and translates it to C++, and there were no errors, because otherwise we would have seen message about that here. We can also switch to the terminal to kind of understand what really happened. And you can see it actually works by generating a make file that you can find here under the default folder in the target project or target folder. Then it invokes make on that make file, and that in turn will cause all generated files to be compiled, and finally we link them into an executable. And we can also run that executable directly from the TC. So right click here and do run. Then in the terminal, you will now see that it prints hello world after 2 seconds. So the application is working as it should. So this transformation configuration editor is the textual one that you can use maybe if you are slightly advanced user or that prefer text. It's similar to the code tab we have in the TC editor in Artist. So you have things like content assist here, where you get suggestions for all the TC properties that exist, or you can do it here to get the suggestion for all the capsules that exist. In this case, only one. But some users probably will prefer to have a more form-based editor like we provide in Artist. And for that, we have developed a user interface that you can open by right-clicking on it and do Edit Properties UI. Then you get a UI that is a bit similar to what you have in Artist, but instead of having multiple tabs, we have decided to have just one page with all the settings. Here you can see things like there are small buttons there that you can click to get documentation to understand what these properties mean. And here there are also some suggestions that you get similar to the content assist. You can use these drop downs to pick. For example, here I can pick my target configuration. So by default on Windows, it will use MinGUI. But I can also use Visual Studio, and then I change it like this, and you see it updates automatically in the TC file in the corresponding way. If I prefer to update instead here, I can do that as well. With Content Assist, I get the proposal here, and I can do the change there. And when I save this file, it will update in the UI. So these two views are synced. And there are lots of other preferences or properties that you can set. I will not go through them now because they are a bit outside the scope of this presentation. But those of you that know artists will recognize them. They are exactly the same. So for now, I will just delete this line because it's unnecessary to have it. So this was the simple example working like this. So now let's try to change it a bit and observe what happens in the diagram when I make some changes. So for example, I could change this so that instead of going from S1 to S2, I could stay in S1 and handle this timeout event with an internal transition. That is probably what I would have done if I would have created this sample from scratch. And to do that, we need to add an internal transition inside S1. So S1 is up here, and we can add a curly bracket like this to be able to put something inside S1. And control space will always propose you the elements that can be created at this particular point in the file. So here you see you have lots of options of things that can be placed inside a state. And you can create an internal transition, for example. So for the internal transition, you are encouraged to provide a name. So we can call it maybe on timeout. And then you are supposed to tell the trigger, and the trigger is same as down here. So we can just copy that and paste it here. And then let's put the code that we have down here up here instead. And this, for those of you who worked in Artist, you know that these things actually take a bit of time in Artist because you need to select different transitions, you need to copy from the code view and paste in another view. Here in the text, it's very, very simple. And then we can delete this transition. And then now you see diagram updates, the transition is gone, but we still have S2, but we don't need that also. So let's delete S2 also. So now we've simplified our state machine. We just have the one transition for initializing, setting the timer. And then we have an internal transition now on S1. And you can see there is a small arrow that shows up here. Same symbol as we use in Artist. So we don't show the internal transitions inside the state because there can be quite many of them. So for now, you have to select the state and then you will see it instead in the properties view up here. So we have different sections here that you can collapse and expand. Currently, there are not too many, so you can have them all expanded. And if there is just one transition like this, then it's will not even become a scroll bar here. But in a more realistic model, there will probably be a scroll bar so that you can select which internal transition you're interested in. We have the same icons here, so double-clicking here will show the C++ code that will run when this transition is triggered. So let's build this sample now after it has been refactored. I will do just like before, invoke build, and we should expect it to work. Yes, it did. So now we can run it again, and we should see exactly the same output as before. Yeah, it works. Yeah, so that was nice. So now maybe let's try to introduce some error because it's quite common when you're typing things that you make some mistake. So assume that you are using not arrow here, but a dot instead, because maybe you don't know that this context function actually returns a pointer. So let's save it and then build again. Now we would expect a compilation error to happen. And we do get it. And here in the output view, you now see that build completed with errors. See terminal for details. So we took the decision not to copy all the errors here in this place, like we by default do in Artist. So instead, we are trying to keep this like a high-level overview of how the build went. And if user is interested, he can control click here to jump to the terminal where there is all the details about why the build failed. And here we have the compilation message saying that, well, it's actually a quite good message because it even suggests me, maybe you meant to use arrow. Yes, I definitely did that. So I can control click here also to jump to the generated file, because I think this is typical that user will not edit the C++ code inside the art file, at least not often. It's probably much more common that he prefers to edit it in the generated code. And that is fine. Just like you can do in Artist, you can change whatever you like in the generated code as long as you stay within these comments here. So these comments, starting with USR, mark code sections. So they correspond to the code that you have in backticks here in the art file. And of course there is a hyperlink also here that specifies which code snippet that we are seeing here. So we can just go here directly and change this to an arrow, and then we press save. And when we save, we will automatically update the corresponding code snippet here. We don't pop any dialogue because that's not really how VS Code works. So we just do it without any questions. And that's how we can fix the problem, and then we can build again using this build command. Can also mention that some users that are a bit more advanced might prefer to use the terminal instead of invoking everything from the context menu. And that is very easy thanks to this command open in integrated terminal that VS Code provides. That will actually open a terminal in the same folder where you had the selection. So here you can now manually just type make, and then it will build the application like it did before. And then you can also use like make clean, for example, then that will remove all the object files, and then you can build it from scratch again. So if you are used to working from the command line, this is probably a much more attractive way than using the context menu, but I think we have both kinds of users. There are some users that definitely would like to do it from the UI, and some that would like to do it from the command line, and maybe some that use the mix between them. So now let's take a look at some other diagrams, because so far we only looked at the state diagram. So we can take a look at the class diagram, for example. But if I would open a class diagram here, it would look a bit boring because there is only one capsule. So it just shows that capsule, and you also see it has a timer port. But let's add a little bit more interesting things to the sample. We can create a base capsule, for example, that we can inherit from. And to inherit, we just type :base. And now you see that two things happen. First, if we open the class diagram again, we now see this inheritance in the usual UML way, that hello world now inherits from base. But also in the state diagram, you see that these dashed symbols and gray symbols appeared here. And the reason, of course, is that when you're inheriting a capsule, you're also inheriting its state machine. So now we got this state coming up from here, from this place here. And also you notice that there is now an error down here. And if you put the mouse over here, we see that the problem here is now that the state machine of capsule hello world has two initial transitions. And one is local, this one on line 30, and the one inherited from the base capsule is here. So obviously we need to fix this problem somehow. And by the way, when you get these kind of errors, you can always use a hyperlink here to open in a web browser in our documentation a page that describes this error. So for every semantic validation we have, and I think currently they are about slightly over 30, we have a description in the documentation and a sample that you can look at for how to replicate that problem, and also some text on how to solve it, of course. But this particular error is not very difficult to solve because we basically need to get rid of the duplicated initial transition, because you can see in the diagram clearly what is wrong. because it's ambiguous when this state machine starts now, whether it should go to state or S1. And probably the best way to fix it is to redefine this initial transition. And to do that, we need to give it a name. So we can call it my initial, and then colon. Then you see it appears here. There is now a yellow mark here, a warning. We also have checks that kind of are not really checking for problems, but more like for conventions. And by convention, names of transitions should start with lowercase. And in some cases, in some simple cases, we even have quick fixes so that you can just click here and select decapitalized name, and then the problem is automatically fixed for you. So obviously this only works in simple cases. It cannot work for very complex semantic problems, but in some cases it's possible to fix them this easily. And now that we have a name for this transition, we can reference it down here. So we can type redefine, and then we can use this content assist, my initial, and then like this. So now what we have done is that we have redefined the inherited transition, and not instead of creating a new one in this derived capsule hello world. And this is reflected in the diagram that now there is only one initial transition called my initial with green text. So green text is currently the way we are showing that something is redefined. We probably should actually change this dashed line to a dash dot line, since that was a feature we recently implemented for Artist, and it would be useful also here in Artist in Code. So I actually just created a Jira for that today that we hopefully can fix maybe next sprint or later in this sprint. And now we can see that, yeah, we can use this as a hyperlink to click and navigate to the redefined transition here if we want to. Are there any questions so far? Okay, let's create some more interesting things here. So S1 is now what we call a composite state, since it has these curly brackets, but it only contains an internal transition so far. We can also create substates within it. If we create a state called nested 1 and another state called nested 2, we then will expect to see them inside S1, and we don't see them immediately. We need to click this little plus sign first to expand. And this is also a feature that is different from Artist. In Artist, you can not look at more than one level of a state machine in a single diagram, at least not without significant effort. But here we are trying to reduce the number of open diagrams. So instead of having a separate diagram for the contents of S1, we are showing it in line here if the user has clicked this expand button. And he can then choose, of course, some case maybe he want to show only this one expanded, and if it has another state, maybe not expanded. So this is something he can select, and we do remember it. So if we close this now, we will detect that there was a change in the diagram, and we can save it. And next time we open this state diagram again, it will be remembered that this state was expanded, so that the user comes in the same, the state of the diagram is the same as when we left it. You may see also that there is a warning icon here. It's maybe not easily seen because of the, we can zoom in maybe, so you can see it better. There is a warning icon here, and if we put the cursor on it, might be a bit tricky now thanks to the label. It's not coming up, but actually that warning is something we also can see here in the problems view, and we can see it here also if we put, there are actually both a warning and an error, I think, and this I think has been fixed in the very latest build, but this is the version from last week where it was not yet fixed. So we actually have a couple of problems here that you can see in this tooltip. And essentially what they are saying is that since S1 now is a composite state, we should use an entry point for entering it. And those of you who took the artist course, you know this, that this is very much recommended to do. So let's create the entry point for S1. We can do it, for example, here. Create an entry point, and we can just give it any name. The names of entry points are usually not so interesting. They just have to be unique. So call it EP1. So by default, entry point names are not shown in the diagram in order to not clutter it, because they are, as I said, usually not interesting. But we have this view preference up here. So if you want to see them, you can click here and then they appear in the diagram, but not usually necessary. And now we should connect this transition to this entry point. At this moment, it's not possible to edit the diagram like that. So you cannot, like an artist, select this transition and redirect it to the entry point. That would probably be the best, simplest way for the user to do it. And it's something we definitely want to support in the future. But for now, these diagrams are to a large extent read-only. Not fully. There are some things we can edit, but they are mostly read-only. So to change this, we need to change here in the code. But we can simply do it by typing a dot after this S1, and it proposes to use the entry point instead. And now you see the diagram is updated, so now we're entering the state on the entry point instead. And then we need to connect it on the inside also, because if it stays here, it's ambiguous where it should go. So we need to also specify that there should be a transition on the inside. So let's create that here. And this would be a non-trigger transition because it cannot be triggered by itself. It can only run when the transitions on the outside has been triggered. And for that kind of transition, we only need to specify the from and the to, and the from is EP1, and the to should be, for example, nested 1. Like this. And now you see the diagram looks correct, and we can even remove this code because we don't need to run any C++ code in this case here. And now we got rid of that blue dot also. So this is currently how you're creating your state machine. You're editing here on the left side, and the diagram gets updated on the right. And it's after you get used to it, it's surprisingly efficient actually to make changes in only by working here in the text and observing what happens in the diagram to the right. We may also want to add some code that should happen when this nested 1 is executed. So then we have to once again make this a composite state, so we can add some entry action code. This option here allows us to put some code to be run when the state machine enters this state here. Here we could type, for example, nested 1 entered. And now it would be nice to run this and show that it actually works, but we have still some limitations in code generation, and one thing that doesn't support is these kind of compound transitions that consist of multiple segments. So if I would run this, it would actually never reach the nested 1 state. So I will not do that. But we can just look here on the generated code anyway, because something is of course generated for this sample. And if I put them next to each other, we can take a look at what happens when I change something here in my, so if first of all, I can navigate to the code by clicking this hyperlink, so I can find the C++ code that corresponds to this code snippet. And if I change something here, like this, you see that the code is automatically updated. This is also different from Artist, because in Artist you need to trigger the build on the TC or at least code generation for this to happen. But here we are doing it automatically 1 second after you have stopped typing. Just the way as we update the diagram automatically, the generated code is also updated automatically. So in fact, you can treat these two as two views of the same model. So we have the model here in the upper left corner, edited in Arch syntax. You have a diagram view that gets updated automatically, and you have a code view here, the generated file that also gets updated automatically. And this is nice because then you can do experiments here and you can immediately see how is this art concept, like a state or transition, actually represented in C++. And you can build up your knowledge about how the code generator works. I mentioned that diagrams are almost read-only, but not fully, and we do support some editing. And one thing we have worked on recently is to support colors to be edited. So if I add a new state here, my state, and select it, you see that there is a property called set color. Here we can click and we get this pop-up where we can pick a color for this state. And then you see that it updates in the diagram. And what happened if we look in the art file is that this text came. This is RT : properties within double square bracket is syntax we have introduced to allow arbitrary properties to be set on elements. So this is how we intend to store all information that the diagram needs to be able to render nicely, basically. So colors, it can also be positions, fonts, whatever we would like to support in the future. But for now, it's limited to colors. But this shows that it's possible to gradually allow things to be edited also in the diagram, and then the text is updated automatically. And then later, of course, the user can choose. Maybe he wants to edit it here instead. So he click here and he gets this tooltip, and he can change the color of the state here from this place also. That can also be convenient sometimes. So the goal is that these two should always be in perfect synchronization. And of course, also maybe he wants to tidy up this a little bit since it was automatically added. So we have this command, right click and do format selection to line break it and indent it a bit so that it becomes slightly more readable. After a while, there might be a lot of these property sections. Then you can use the context menu command fold all C++ or fold all properties. That will simply fold it like this so that it doesn't obscure the view of the rest of the art file. And we have a similar command for folding all C++ code in case you only want to see the art concept and get the high-level overview of what this application is doing. You can get them back both by typing Ctrl+K+J, and then it looks like this again. So we've looked at two kinds of diagrams now: state diagrams, class diagrams, and the last diagram we support are the composite structure diagrams, or just structure diagrams. And to show that, this sample is not so good because it just would look very simple. But we can switch to the ping pong sample, which is slightly more complex, even if I wouldn't say it's complex sample, it's slightly bigger at least. This sample has 3 capsules. We have a top capsule, we have a pinger, and we have a ponger. And usually the best way to understand, and obviously this is the top capsule that we would build, and the best way to understand the application is usually to open the structure diagram on the top capsule. So if we do that, we get this view here where we can see that this application consists of one top capsule that contains of 2 capsule parts, ping and pong. And ping is of course typed by pinger and pong by ponger. And we see there is a communication channel here, a connector, meaning that pinger can send events to pong and pong can send events to ping. And here we have also used the opportunity to have some embedded C++ code. So for example, here I have used an RT-Decl section to type some C++ code. And here I'm declaring a C++ member variable, private member variable called count of type int. This is also another important difference from Artist, because in Artist you would typically do this instead using UML attributes. And UML has its own syntax for specifying types and things like visibility is done by clicking radio buttons in a property page. But this is something we have heard from users that know C++, that they actually prefer be able to type this directly in C++, as they would have done it if they would have hand-coded this application. And now they can do that. So there is an RTDecl, and here in the tooltip you see that this code will be placed into the header file that is generated for the capsule. Of course, there is also an RTImpl section that you can use if you need to have something generated into the CVP file for the capsule. But in this simple example, I don't think we have that. We don't need it. There are other things like in impl preface. Those of you who know Artist recognize this from the code view, that you can specify a code snippet that will be inserted into the beginning of the implementation file. And there are a few other places where you can have your own C++ code inserted. So here, this is commonly used for including header files. Like in this case, I'm using IOStream to be able to print using this cout object. So here you can see the difference. In this capsule, I'm using this IOStream C++ style of logging, while in this capsule, I'm instead using the log port, which is a service that our target RTS provides. And in that case, I would log using an API like this, log.show and log.log and log.commit, etc. What you like is much up to a personal preference, but honestly, I think many people will prefer the C++ way of doing it, like down here. So what this example does is that it starts by the ping capsule sending. I mean, in its initial transition, it will send the ping event with the count variable as data. So it starts by 0, and then every time the ponger receives this, it will just print what it received, and then it will send pong back. And when pong is received by pinger, it will increment the counter and then send it again. So it goes back and forth like this. And it also uses a timer so that it shouldn't go too fast. So it's 1 second timeout between every ping pong. So just like before, we need a TC for building this. It's very simple. We just need to specify the top capsule, and then we right click on it and do build. And hopefully it should build without problems. Now you see there were significantly more files generated and compiled, because every capsule is generated into its own file. So you see we got a pinger, 2 files for that. We got a ponger. We got for a protocol, we got files for the top capsule, and we get this unit name that we always get. And the build was successful, as we can see here in the output tab, and then we can run it to see what happens. And you see it starts sending ping and pong, and for every time it increments this counter, and it goes on forever. And it's not more interesting than this. So I will terminate it by pressing Ctrl C twice here in this terminal. Yeah, what more can I show? Maybe one thing I forgot to mention when we talked about editing is that another thing we allow to edit is renaming things. So you can rename either, of course, from here by going, if you go to this My State, for example, you can rename things by pressing F2. Then you get this dialog and can do the rename here. And the difference between this kind of rename and just replacing the text is that all references to this state also will be updated. So for example, if I want to rename nested1 that we are referencing here, I want to change it maybe to nested11 instead. You see it also updates the reference automatically. So this is what is in Eclipse called a refactor rename. And that is recommended when you want to rename an object. That you can also do from here. So just double clicking on a name here, you can just change here. But actually what will happen is that the change first happens in the text file and then the diagram updates automatically. So it's not really a diagram update, it's more like invoking the refactory name from the diagram, and then the diagram updates as usual, as if the user would have changed this himself.